let's discuss about topic on calculus. What is calculus? Calculus is a primary mathematical tool for dealing with continuous change. What does this change mean? Say, for example, if you have to determine the speed in which a vehicle needs to travel given distance and time, and if the speed keeps increasing, what is its impact on the distance and time? Or if distance is increasing, what is the change in speed? Similarly, if you have to find the force given density, mass, etc. So if there is one parameter changing, what would be the impact on the remaining parameters is what is defined by calculus. There are different areas where calculus is used. So wherever there are multiple parameters are there, and if wherever you have to determine the impact of one variable or one parameter on the remaining variables and remaining parameters, then we need calculus. For example, it's used in biology to determine the rate of bacterial growth in a given culture. Similarly, in meteorology department, if you have to find the rate of change in atmospheric pressure, or if you have to find the weather, or if you have to determine the weather forecast, cyclones, storms, etc. Similarly, it's used in economics to calculate profit given the cost and the revenue. It's used in medicine, engineering, geography. If you have to determine the rate of change or rate of increase in population in a given city. So if you notice, all of these changes are dynamic, and the changes keep happening. It is continuous. So in such cases, calculus is a powerful mathematical tool which helps you to find the ratio of change, the quantum of change within the different set of parameters. Calculus is broadly divided into two wide topics. One is differential calculus and integral calculus. And the basics for differential calculus and integral calculus is limits and continuity. So limit, as it states, it is nothing but for every value, for every parameter, there is a limit defined. For example, speed of a car. Normally, there is a safety limit or there is a maximum limit for the speed of the car. It could be 180 km per hour, 200 km per hour, depending upon the car brand. Similarly, if you take biology, the rate of bacterial growth. So the quantum of bacteria that can grow depends upon different parameters such as the environment, the food source, the temperature. All of these create an impact on the growth of bacteria and vice versa, right? Similarly, in the field of economics, where we will have to define the growth rate of profit given the cost and revenue. And also in the case of geography, we may have to determine the rate of growth of population in a given city. So let's take an example. Say we have two cars, car 1 and car 2. The distance between these cars is 5 kilometers. And car 2 is heading towards its destination. So say this is its destination or the final point. Car 2 is, say, traveling at 60 km per hour. Now, car 1 also wants to reach the destination at the same time as car 2. But it is 5 km behind car 2. In this case, the speed in which car 1 has to travel should be more than 60 km per hour. Say, for example, it should be 65 or 70 km, say. So, if this is going at 60 km per hour, car 1 needs to go at, say, 70 km per hour. Roughly, I'm just using these numbers to demonstrate this particular change in speed. Now, say car 2 is going to increase the speed to 70 km per hour. So what will happen to car 1? This one also will have to increase. So this will increase by 80. Now, what if car 2 is continuously going to accelerate till it reaches its destination? So it will be 70, then it will go to 80, then it will go to 100. It will keep on going. And at one point it will say it will go till 180 km per hour. Now, the speed limit for car 1 and car 2 is 180 km per hour. This is a speed limit, right? Just for an example, say speed limit of both the cars is 180 km per hour. Now, if car 2 decides to go at the speed of 180 km per hour, what's going to happen to car 1? It has to increase its speed further, maybe 200 km. But is this acceptable? This is not acceptable because the speed limit is itself 180 km, right? So there is a limit defined here. The limit is 180 km. So this becomes a limit. Now, if I were to express this in the form of a function or an expression, say I would call speed of the car as x, for example. Speed of car 1. If speed of car 1 is x, then speed of car 2 is, say, y. So I can write this as an expression which is y is equal to x plus 10. So, which means speed of car 2 is speed of car 1 plus, say, additional 10 km per hour speed. Right? Just in this example, I have taken that if car 2 is going at 60 km, car 1 is to go at 70 km to match up the time. If this is going at 70, then this has to go to 80. So I'm roughly putting that there is a difference of 10 km per hour. Right? So now I can write this also as, this y I can write as f of x. Right? Basically y is dependent on x. Y is nothing but a function of x, or y is an expression which is dependent on x. So I can write it like this also mathematically. Now I have to define a limit here. So how do I express this in the mathematical equation? I can write it as limit x tending to 180 km, because 180 is the limit. The speed of car x is nothing but speed of car 1. The speed of car 1 can only go till 180, right? So I'll write it as limit x tending to 180 x plus 10. So this is nothing but a limit function. There is another concept called as dependent variable and independent variable. Now if you take this expression, what is an independent variable? X is an independent variable. X is an independent variable. Why it's an independent variable? Because x can take any value from 1 km per hour till 180 km per hour. So the car 1 has the freedom or independence to decide the speed. Whereas y, that is car 2, it cannot determine any speed that it wants to travel at. It is completely dependent on the speed of car 1. It is dependent on x. If x increases in speed, y also has to increase. If x decreases, then y also has to decrease, because y needs to meet the distance at the same time as x, right? So which means y is dependent. Y is dependent variable. There are different types of functions or expressions. One is polynomial function. Polynomial function is nothing but an expression which has multiple terms. So if you see, there are 3 terms here, x cubed, 2x and 5. So any expression that has more than 2 terms becomes a polynomial function. Modular function. So any expression that has mod x, say for example mod 3. Modulus function is nothing but it does not care about negative numbers. It will always be positive. So if you have something like mod x, or if you have mod minus 3, then it is always 3. Mod 3 is also 3. The number is always positive. So if you have an expression with mod, then it is modulus function. Third one is exponential function. In any expression, if you have e, right? E is nothing but the exponent. The value of e is 2.718, right? E is equal to 2.718. And if there's any function where log is there, right, then it is logarithmic function. Rational function, as the name itself indicates, it's a ratio or it's a fraction, right? Anything of this particular form is a rational function. There are different ways of evaluating these functions or limits, right? We have to evaluate the limits on a given function or an expression. So in the earlier example, we used the car example, right, where f of x is equal to x plus 10 and the limit x tends to 180. Now what does this mean? We can substitute x as 180 and anything less than 180, right? Anything around 180 can be substituted. So we could substitute x is 60, 70, 80, 90 till 180, right? So this is called as direct substitution. So if I say x tends to 180, I can simply write it as f of 180 is equal to 180 plus 10, which is nothing but 190. That is f of x is equal to 190. There is another way of evaluating limits. The other one is factorization method. In factorization method, say for example, you will have an expression like this: x square minus 9 by x minus 3. You have limit x tending to 3. So here what's going to happen is, if I apply substitution, say I substitute x as 3. So I will get 3 square minus 9 by 3 minus 3. So this will become 9 minus 9 by 0, which is 0 by 0. See, this is not acceptable because 0 by 0 in mathematics is indeterminate or infinity. We cannot have a value like this. So what we do, I can write x square minus 9 as x square minus 3 square by x minus 3, which is nothing but, I can write x square minus 3 square as x plus 3 into x minus 3 by x minus 3. Always remember this. This is of the form a square minus b square. When you have a square minus b square, this is same as writing a plus b into a minus b. You can verify this, but this is very important. We'll have to use this expansion in most of the problems. So whenever you get something like this, x square minus 3 square or x square minus 5 square, x square minus 8 square, every time expand it like this, x plus 3 into x minus 3. One will be a positive expression, the other one will be a negative expression. Now what will happen in this case, you'll cancel x minus 3 and x minus 3 and you'll be left with x plus 3. Now you will apply substitution method. So limit x tending to 3 would be 3, I'll substitute x as 3, so it will become 6. There is another method, third method, which is called as rationalization method. In this case, why do we have to rationalize? What do we mean by rationalize? Rationalize is whenever you have square roots, you normally rationalize because you want to get rid of square roots, especially square root should not be there in the denominator. Now this is one of the ways to simplify the problem. Once you rationalize, you can substitute using the substitution method. That is, you can directly apply x as 0 and substitute. But in the first step itself, we can't substitute because what's going to happen if you substitute, it's going to become 0 by 0. So it will become root 2 minus 0 minus root 2 plus 0 by 0. So denominator is going to be 0. This is going to become 0 by 0, which is not acceptable. So now we are going to simplify by rationalizing it. Now how are we going to rationalize? We are going to take the numerator here and multiply and divide both the numerator and denominator by this particular expression. That is, I'll take this expression and I'll multiply and divide by same thing, but I will change this minus sign to plus sign. So what I have done, I have multiplied and denominator by the same this expression, but with plus sign in between. So I will calculate this, right? Root. So this is again, this is of the form, the earlier one that you saw, a square minus b square is equal to a plus b into a minus b. So now you can call this as, this entire thing as a, this is b, a plus sign here, this entire thing is a, entire thing is b, and minus sign here. So it's of the same form, a plus b, a minus b form. So always use, this is a very important one for limits and continuity, right? So now what we're going to do, we're not going to multiply each term, right? We're not going to do multiplying this with this, this with this, this with this, this with this. We will simply use this formula, which is a square minus b square. What is a now? A is root 2 minus x, the whole square, because it's a square, and minus b square. B is root 2 plus x, the whole square. And the denominator is, we have x into root 2 minus x plus root 2 plus x, right? Now we'll have to multiply this. You have root and square here. So when there is a root and square, it will get cancelled. This is square root and this is square, it will get cancelled. So it's going to become 2 minus x minus 2 plus x. And this one we will have to multiply. We'll just leave it like that. We will not multiply because we will have to substitute it later. It's not necessary that you multiply in such cases. Leave it till the last step. So now what we are going to do, this is going to become 2 minus 2 is 0, minus x minus x. So you're going to get minus 2x by the same. Let's put the same thing here. Minus 2x by x into 2 minus x plus root 2 plus x. So now we can cancel x here and x here from numerator and denominator. So we'll get minus 2 by root of, this is nothing but limit x tending to 0. I'm just copying this as x. Now I will substitute x as 0 here. So I'll get minus 2, x is 0. So root 2 minus 0 plus root 2 plus 0, which is nothing but minus 2 by 2 minus 0 is 2, root 2 plus root 2. So what am I going to get? 2 by root 2 plus root 2 is nothing but, assume that there is 1 here, 1 plus 1. So it will be 2 root 2. 1 root 2 and second root 2 becomes 2 root 2. Now again 2 and 2 will get cancelled. So we'll be left with 1 by root 2. So this is the answer. So let's go to the fourth method of evaluating limits. The fourth method is nothing but applying the theorem. Theorem states that limit x tending to a, x to the power n minus a to the power n by x minus a is equal to n into a to the power n minus 1. So we will have to by heart this, right? We will have to memorize this theorem. We will have to also understand the derivation of this particular theorem. So many a times they've asked in examination papers as to how to derive or how is this particular formula derived, right? For now, let's memorize this theorem. So let's take an example as to how we can apply this theorem. Limit x tending to x cube minus 8 by x minus 2. Whenever you have something like this, right, we'll have to use the theorem. That is, you have x cube here and you have x in the denominator. You have 8. So we'll have to represent this 8 in the form of 2. So what is 8 actually? 2 cube, 2 into 2 into 2, right? So we'll write it like this. Limit x tending to 2, x cube minus 8, we'll write it as 2 cube by x minus 2. Now you don't have to think a lot to find out as to how you write the power, right? Simply take the 2 in the denominator, because we have 2 in the denominator. Just represent this particular number 8 using 2. So we have used 2 cube here. Now if you look at this particular theorem and this one, isn't it similar, right? Here you have x, instead of a here you have 2. So a you have as 2, n is nothing but 3, a to the power n, that is nothing but 3. So now what's going to be the formula for this? N, what is n? 3, n into a to the power n minus 1. N is 3, a is 2, 3 minus 1, n minus 1. So it's going to be 3 into 2 to the power 2, which is 3 into 4, nothing but 12. Now let's take a slightly complicated example. Here you'll have to apply theorem both for the numerator and denominator. So the formula is n into a to the power n minus 1, right? That is x to the power of n minus a to the power n by x minus a is n into a to the power n minus 1. So now if you look at the numerator, you have x and in place of a you have 1024. Now if you observe, the denominator should have x minus a, that is, it has to be x to the power 1, that means it has to be only x, right? But if you look at the denominator here, you have x to the power 4. So now what you'll have to do is, you'll have to write it like this. So let's write 1024 in the form of 2. So how many times in 2 tables will you get 1024? 10 times. If you multiply 2 10 times, right, 2 into 2 into 2, if you go on till 10 times, then you're going to get 1024. Now similarly we'll do for the denominator also. 16 is nothing but 2 to the power 4, right? 2 into 2 into 2 into 2. Now we cannot apply the theorem here, because for the theorem we need to have, it should be of this form, right? We should get of the form x minus a should be there. That means we should get x minus 2, because a is 2 here, right? And here also we should have x minus 2. Only then we can apply this theorem. So what we are going to do, we are going to put this x minus 2 in the numerator and x minus 2 in the denominator also. That way this entire expression is balanced, because you are putting this extra x minus 2. So you'll have to balance it out. You'll have to put it in the numerator also, you'll have to put it in the denominator section also. So now you'll apply the theorem. So this is of the form, this theorem. So what is n here? N is equal to 10, power is 10, a is 2, 10 minus 1. Similarly for denominator also you'll apply. Power is, that is n is 4 and a is 2, 4 minus 1. So you will get 10 into 2 to the power 9 by 4 into 2 to the power 3. So if you calculate this, you're going to get 160. So to summarize, right, you have x to the power 10 and x to the power 4. We cannot directly apply the theorem because the denominator should have x minus a form. That means there has to be x only in the denominator. Here we don't have. So what we are going to do is, we are going to put it as x minus 2 in the numerator and x minus 2 in the denominator section. And then we will also write this 1024 in the form of 2 to the power 10. Similarly, here we will write 2 to the power 4. And then we'll apply the theorem and get the value. Let's go through a topic on sum product method. What is sum product method? This is a method or a technique that is used to obtain the factors of an equation. Say for example, we have 2x square minus 5x plus 2. This is a quadratic equation. So if you have to simplify this, or if you have to factorize this equation or obtain the factors of this equation, then we use this technique. Now, how to use this technique? So first, we'll have to focus on all these numbers here, right? 2, minus 5 and 2. Now, product and sum. If you multiply coefficient of x square, which is 2, and this constant, which is 2, when you multiply this, it's going to be 4. And sum minus 5. This 2 into 2, both are positive numbers. So it's going to be plus 4 and minus 5. So you have to choose two numbers whose product is plus 4 and whose sum, or if you add those two numbers, you should get minus 5. So basically you're using all the coefficients and constant given in this equation and trying to obtain factors. So to get the factors, we need to get two numbers whose product is 4 and whose sum is minus 5. We have to take the signs into consideration here. So here plus and plus is plus, 2 into 2 is 4, and minus 5 is what we have as coefficient of x. Now let's choose two numbers. There can be multiple combinations. You can have 2 in 2 and 2. You can have 4 and 1, right? That is, these are the two combinations where if you multiply 2 and 2, you'll get 4. You multiply 4 and 1, you'll get 4. So there are two ways. But it also has to meet a condition where when you add these numbers, it has to become minus 5. So if you take 2 and 2, if you add 2 and 2, it's not going to become minus 5. So we'll not take this. We'll go with the second combination, which is 4 and 1. If you take 4 and 1, if you add 4 and 1, we are going to get 5. So this is the right combination. Now we'll have to get the signs correct. We need to get minus 5 here. So what we have to do to get minus 5, we will have to use minus in both the numbers. Why in both the numbers? Because minus 4 and minus 1 is what is going to be minus 5. And minus 4 into minus 1 is going to become plus 4. So that's where we'll have to use minus 4 and minus 1. Not in every problem will you have both the numbers as negative. You could have one number as negative, the other number could be positive. So in this case, both are negative. So what are the factors here? You'll have minus 4 and minus 1. Now we'll have to use these numbers in this equation. How do we use it? We will, instead of minus 5x, we are going to put minus 4x and minus 1x. So basically we are going to split this second term here like this. Minus 4x and minus 1x. That is these two numbers. And we are going to put x to it. So then we are going to copy the rest, plus 2, and we have 2x square. Now what we are going to do is, we'll club these first two terms and last two terms. We'll take the common factor out. You have 2x square minus 4x. Let me write this neatly. 2x square minus 4x minus 1x plus 2. Let me take 2x as common between these two. So it will be 2x. You'll be left with x minus 2. Similarly, now you'll take common between these two. You'll take minus out because you want to make it in this particular form. If I take minus out, I'll be left with x. Since I've taken minus out, here it will become minus. Now you notice, again in this entire expression, x minus 2 is common. So if I take x minus 2 as common, I'll be left with 2x here, and here it's going to be minus 1. So this is the factors of this quadratic equation. Let's take another example. This is similar to the example 1 with a slight variation in the signs, right? So now I'll write it as sum product. So what should be the product here? It should be multiplied by 3 and 2. You should always take the coefficient of x square, that is a number adjacent to x square, which is 2, and the constant, which is 3. So multiply this. 3 into 2 is 6. And what is the sign? This is plus. This is also plus. So it's going to be plus 6. Now, for sum, we'll have to take this number. It's plus 5. That is coefficient of x. Now, let's find the numbers. Number 1 and number 2. So, to get 6, what are the two numbers we can take? We can take 6 into 1 and we can take 2 into 3. Is it not? There are two combinations again. Now, which of this is right? That we will have to figure out. So, here I can't add 6 and 1 because if I add 6 and 1, it's going to be 7. So, this combination is not going to be possible. If I add 2 and 3, I'm going to get plus 5. So, this is possible. The advantage here is both are positive numbers, so I don't have to really worry about the signs. So, the numbers are 2 and 3. So, let me split 5x as 2x and 3x. So, 2x plus 3x is going to give me 5x. Let's put this here. So, 2x square plus 2x plus 3x plus 3. I have substituted 5x as 2x plus 3x. Now, I can take the common between this 2 and this 2. Always take the common between the first two terms and the last two terms. So, if you see the common factor here is 2x. So, if I take 2x out, I will be getting 1x and plus 1. Similarly, I will take 3 outside here. So, I will get x plus 1. Now, again, if you notice, x plus 1 is common between both. So, I will take x plus 1 as common. I will be getting 2x here plus 3. So, these are my factors. Let's take another example. This is slightly different. It is x square minus x minus 2. Why it is different is, here x square doesn't have a coefficient. Basically, in early examples, we had 2 there. Here we just have 1. Nothing means there is 1. So, in this case, it's going to be a little more simpler, right? But we'll have to use the same method, sum product. What should be the product? It should be multiplied, this number multiplied with the coefficient of x square. This is 2 minus 2 and this is plus 1. So, it's going to be minus 2 into 1, which is minus 2. What is sum? Sum has to be this one, this particular term, right? This is sum, this is product. So, it should be minus 1. Now, we have to choose two numbers where the product is minus 2 and sum is minus 1. So, numbers could be 2 and 1, right? This is the only combination I can think of. 2 and 1 is the only combination where if you multiply, you're going to get 2. So, 2 into 1 is 2 and 2 minus 1 is also 1 here. So, this satisfies both the conditions. But let's check the signs because here both are negative. So, we need to know where we have to put signs. We can't leave it as plus 2 and plus 1 because the product has to be minus 2. That means one of the numbers have to be minus here, right? Which number has to be minus? That we can confirm by adding the numbers. Now, if you add the numbers, you have to get minus 1. How can you get minus 1 if you add 2 and 1? That means one number has to be negative. So, minus 2 plus 1 is minus 1. Because there is minus here, the larger number has to be minus here. Larger of these two numbers is 2. So, it will be minus 2 and 1. So, the addition, that is the sum condition is satisfied. Does the product condition get satisfied? Minus 2 into 1, that is minus 2 into 1 is minus 2. So, this is satisfied. Minus 2 plus 1 is also minus 1. So, this condition is also satisfied. So, the numbers are minus 2 and plus 1. Now, here it is slightly simpler. We will directly write x minus 2 and x plus 1 here. That is, we'll put x, then we'll put minus 2. We'll put x and we'll put plus 1. That's all. We got our answer. You can verify. You can use the earlier method also. That is what we did in the earlier method. We split this minus x, the middle term, using these numbers. How did we do? We did it as minus x. We wrote it as, we should write it as minus 2x and plus 1x. So, we are going to write minus x in this particular form. So, now what we did next, we took the common factor. So, here x is common. So, we'll get x minus 2 and between these two plus is common and I'll leave it as x minus 2. So, again you see x minus 2 is common between both. So, I'll get x from this expression plus 1. So, I got the same answer. Look at this. Both of these are same. So, instead of doing this 3 additional steps, you can directly write, when you get these numbers, you just write x minus 2 and x plus 1. So you can use this technique only when the coefficient of x square is 1. That is, this x square has to not have any other number like 2 or 3 or anything. It should be just 1. That is plain x square. Only then you can use this direct technique. Let's take another example where we have x square minus 3x plus 2. How do we get the factors here? Let's write sum product. So when the product should be numbers multiplied with 2 and this coefficient which is 1. So you'll get plus 2 and sum should be nothing but minus 3, this number. So it will be minus 3. So the numbers that can be multiplied and it should give plus 2 as the product. What are those numbers? It can be 2 and 1 because 2 into 1 is 2. 2 into 1 is 2. And it also has to satisfy the sum condition. That is, if I add 2 and 1, I should get 3. 2 plus 1, I should get 3. I am getting 3, but I have to get minus 3. So that means both of these numbers should be minus. Only if both the numbers are minus, then I am going to get minus 3. If one number is minus, then it's going to be something like this. It's going to be minus 1. So I can't take this. I'll have to take this. So the numbers are basically, again, if I take minus 2 and minus 1, am I going to get plus 2 as the product? Yes. So if I take these two numbers, the product rule and the sum rule is satisfied. So numbers are minus 2 and minus 1. So I will directly write, I don't have to split and write, I'll directly write x minus 2 and x minus 1. So these are my factors. Let's take the concept of rationalization. Rationalization is a concept of simplifying the equations when there are square roots especially. Now, how do we do that? Take this example. You have square root here. Now, if you have to simplify this, rationalization is one simple technique. So what we'll have to do is, we'll have to multiply and divide by a common expression. So we'll take the expression which has square root. That is this one, right? We'll take this expression as is, and instead of minus, we are going to put plus. So basically, it's going to be 3 plus x plus, notice this, plus root 5 minus x. We are going to multiply and divide with the same expression. And then we multiply and the equation gets simplified. Let's try it out. So now one more key formula you'll have to remember is, this is of the form a plus b into a minus b. The basic reason why we rationalize or why we put a positive sign when there is a negative sign here in between is so that we can apply a simple formula like this. A plus b into a minus b is a square minus b square. So what's going to happen when you do that? Square root is going to get eliminated because we are going to have a square here and square root here, it's going to get cancelled. So what's going to happen? We'll have 3 plus x. This is a plus b. This is a minus b. This is a plus b form. So what is a here? A is root 3 plus x and minus, what is b here? Root 5 minus x. Right? We are using this, the whole square, because it is a square minus b square. Now, let's put the denominator as is. Root 3 plus x plus root 5 minus x. Now, we will get this cancelled here because square and square root will get cancelled. So this is where it gets simplified. So we are going to get 3 plus x minus 5 minus x. Don't forget the brackets here. So you'll have x square minus 1 and 3 plus x plus 5 minus x. What's going to happen here? 3 minus 5 is going to be minus 2 and x plus x. So it's going to be 2x by the same thing. So this is an example of a rationalization. Now here we can simplify further by multiplying or by substituting, but this is the main technique of rationalization. Let's take another example. Say we have x square minus 4 by root x plus 2 minus root 3x minus. How do we rationalize here? We'll have to first multiply and divide. Right? Let's write the original expression as is. Right? Let's copy it here. Now we'll have to multiply and divide by an expression. What should it be? Should it be this one or this one? It should be the one that has square root. So this one. So we will just write this as is 3x minus 2. Now what should the sign be? Here we have minus, so the sign should be opposite, it should be plus. So same thing we'll have to do in the denominator also. So we have multiplied and divided by this particular expression. Now, if you multiply these two, you see this is of the form a minus b and this is of the form a plus b, right? Root x plus 2 is a, root 3x minus 2 is b. So what do we get when we multiply a plus b into a minus b? We'll get a square minus b square. Now what is a? A is root x plus 2, the whole square, a square, minus, because it's minus here, b square. What is b? 3x minus 2, the whole square. Now the square and root will get cancelled. So this is the advantage of rationalizing with an opposite sign. So we are going to get, I'm not going to write the numerator because I just want to explain the technique of rationalization. So we are going to get, something will be there in the numerator. Denominator is going to be x plus 2 minus 3x minus 2, which is x minus 3x is minus 2x and 2 plus 2 is plus 4, right?